Hey guys, it's time for another edition of the PCPer Mailbag with your host, the PCPer guy, Ryan Shrout. I've got a host of questions for you. As always, if you want to leave a question for me, do it in either the comments of the news story on PCPer or do it in the comments of the YouTube video itself. And we will filter through those and pick out some that I feel like I'm competent enough to answer or are funny or good or bad or whatever in all kinds of different ways. So let's go ahead and jump right into this. We have a question from Shady Brady, who wants to know what in the world is going on with 1440p G-Sync displays. There are hundreds of negative reviews on all of them related to operational defects, light bleed, color accuracy, or all of the above. What gives? Is there a good 1440p monitor available with G-Sync? And why are all these monitors plagued with problems? So I will freely admit to not being super aware of what these changes are. It's actually been, there haven't been a whole lot of new G-Sync displays coming out that we have gotten into the offices, right? So if there is some kind of systemic deficiency in the production of these panels, it's probably more of an issue of trying to cut costs, cut corners in the production side. I don't think there's anything inherent. In fact, I know there's nothing inherently negative about G-Sync or FreeSync for that matter that necessitate there to be light bleed or color accuracy issues or operational defects or anything like that. This is really a QA issue with the monitor vendor, OEM, whatever you want to have it. You mentioned, Shady Brady here mentions 1440p specifically. I don't know if that means that like 4K monitors aren't showing this, 3440 by 1440 monitors aren't showing this, 1080p monitors aren't showing this. I'm also curious what kind of the perception is around IPS versus TN versus VA, right? So, you know, if you have TN panels, in general, they tend to have poorer color accuracy than VA or IPS screens out of the box. Light bleed is something that can really affect any monitor, regardless of the panel quality, size, resolution, all that type of stuff. And actually, a lot of the light bleed stuff can be fixed by the consumers by, you know, tightening up some of the framing around the backlight and that type of stuff too, which you shouldn't have to do. I obviously admit that to be the case, but it is an option if you want to do that. I don't really know why these monitors, if you're saying this, tend to be generally plagued with these types of problems, but I will ask around and kind of see what it is. And if you guys have links to Reddit threads or maybe even like Newegg threads or something like that that are worth looking into, I will gladly do so. Here's a question from Muad'Dib76. How noticeable is tearing going to be without G-Sync if you're running a high refresh rate monitor at a high frame rate, i.e. a 144 hertz monitor with a 1080 Ti pushing 200 frames per second? How important or necessary is G-Sync in this type of situation? I feel like this might have been something we touched on a little bit last week as well. But the benefit of G-Sync is twofold, right? Or FreeSync. You don't have the stutter or judder associated with frame rates that are below your maximum refresh rate if you have VSync on, and you don't have horizontal tearing if you are anywhere in that any frame rate really with VSync off. Now, as you increase your frame rate, as you increase your refresh rate, the impact of G-Sync is going to be lessened some, right? So in this scenario, if you're running a game at 200 FPS, maybe your Overwatch on a 144 hertz display, essentially what you're doing is 144 hertz is the indicator of how long each picture is going to be on your screen, how long each refresh takes to occur. And at 200 FPS, you just have some, you know, the frequency overlap between when there are going to be multiple frames on the screen at the same time. Sometimes you're going to have just one, there'll be no tearing. Sometimes there'll be 2 frames, you'll have 1 tear, and maybe sometimes you'll see 3 frames at a time and you'll have 2 tears on the screen. It really just depends. But as you go up to higher refresh rates, those tears are on the screen for less time. And the deviation between the first frame and the second frame, like if you have a vertical line, you know, it will be, let's see if I can do this on the video, you know, with a 60 hertz monitor and your mouse movement, it may be this far apart between the tear, but with 144 hertz, it may be this far apart. So the difference between the two frames will be less as well because the refresh rate and the frame rate is higher. So it's definitely lessened as you go through that way. I would still posit that it is a really great capability to have for a monitor, G-Sync or FreeSync, because the idea is, even if you have a 1080 Ti today, there's a game going to come out like Hellblade or something like The Witcher 3 at that time when it was released that really pushes your system, and you're going to maybe want to push the visuals up higher so you can run at, you know, maybe you're running at 100 frames per second. Now, all of a sudden, if you're running at 100 frames per second on a 144 hertz panel, G-Sync is way more valuable than it would be otherwise. But in your hypothetical 200 FPS on a 144 hertz monitor, then yes, it's less useful as a technology. It's less necessary for optimal kind of gaming experiences. Michael Brody asks, if an application, including games, is not CPU bound, is there any advantage in overclocking the CPU? So that's interesting. So, I mean, the easy answer is no, right? If it's not CPU bound, then improving the performance of your CPU would not give you a performance advantage in that particular application. Now, that being said, chances are, even if a game is not CPU bound, there may be other areas where you see some advantages, right? So maybe the driver kernel will go a little bit faster if you're overclocking, right? And keep in mind, when I'm talking about here, overclocking, the advantage is you're not worried about, you know, upgrading from a 4-core to an 8-core processor and wondering if the system can even handle or take advantage of the extra threads at all. What you're really doing is, can the system take advantage of extra frequency? And almost inevitably, the answer to that is going to be yes. More frequency always translates into better performance. The question at hand is, will you see any advantage in that game or in that application? And I would say probably not, right? Now, what you can have is you can have environments where a game may not be CPU bound, but it may be CPU sensitive, right? Meaning that it's just less GPU bound than you might have thought, right? So when we look at stories that when you look at stories that are testing a whole bunch of CPUs and a whole bunch of GPUs in a particular handful of games, you may see some games that will just scale almost linearly as your GPU power goes up. And in those instances, you know, the CPU changes may result in nothing. But maybe in some games we've seen where CPU, you might get an extra 5% as you go up, and in GPUs, you may get 20% as you go up each type of step, right? Just kind of making these numbers up. In that case, the extra frequency will be useful, but not as useful as you might have expected in a game that is legitimately, completely CPU bottlenecked. You know, like I said, the general answer is no. If your application is not CPU bound, improving the performance of your CPU will not give you any advantages. But I would say in general, there are very few instances where any one game scenario or environment that you have set up with your Windows PC in general, right? Gaming plus other things going on in the background is ever truly, completely bounded by one single component. Here's a question from I guess. Why are the chips used in smartphones so different from those used in servers and desktops? In other words, why is Intel not even present in the smartphone market while a company like Qualcomm is so huge? Man, you could spend a lot of time on a question like this. The general answer is, what is the target segment product for these processors, right? The chips used in smartphones have very, very tight thermal limits, right? If you're looking at something like a smartphone like this, you're limited to like 2 watts, maybe, okay, maybe even less than that as you go through different segments of the market, right? 2 watts is not a lot of power. If you look at something like the Core i7 7700K, it has a TDP of 95 watts. You look at the Threadripper processor, it's 180 watts. So you have to think about and design an architecture in such a way that it is more cognizant of power efficiency. And that's really the key there, is right. Like, you design an architecture for that specific target market. And when you don't, if you're trying to shoehorn things into other places, you have deficiencies, right? So keep in mind that though Intel is not present in the smartphone market, they tried to do so, that for several years, and they just got out of it maybe a year and a half ago or so, where they were trying to build chips for smartphones because it was this huge untapped market for them that they and investors saw value in. And though there were a handful of phones released that did use Intel processors and they were fine, it just wasn't what the market wanted. It clearly had some deficiencies in other areas. If they were legitimate, competent, price equivalent parts, then there would be partners still using them today. That's just not the case. Qualcomm from day one has been designed or has been designing chipsets, processors, DSPs, GPUs known to have severe restrictions on thermals and power consumption, right? And so it's very different, right? The ARM architectural and instruction set is based around targeting these specific markets. When you start to look at them reaching outside of that, when you see ARM platforms going into Chromebooks, you're going to see Qualcomm Snapdragon processors going into notebooks, 2-in-1s, traditional Intel areas, right? It's going to be very interesting to see if Qualcomm's Snapdragon processors have the performance and characteristics necessary to compete in that space. Now they're suddenly taking a chip, Snapdragon 835 that was designed for a 2-watt TDP and saying, well, okay, now you have 8 watts, 9 watts of power available to you in this form factor. What can you do with it? So can the processor scale in frequency and still maintain a balance on its performance efficiency curve? What about in its GPU performance, right? What other advantages will it have in terms of DSP integration, modem integration? All this type of stuff was going to come into that story. So it really just comes down to what is the target of the design and knowing what demographic you're going for. Processors for PCs have very different thermal budgets, and thus the architecture, the out-of-order design, the caching structure, the GPU structure, tiled renderer versus immediate mode renderers, all of these decisions come into how power efficient do you need to be and what total power do you need to hit. So also keep in mind that something like the Snapdragon 835 is very, very small in terms of physical die space compared to a 7700K or even, an Atom processor that we might have seen before. So again, we could go a lot more detail on that. If you guys have more specific questions in that area, feel free to let me know. But we could literally just spend forever talking about that specific stuff. Excuse me. Jack Chen wants to know, I am contemplating jumping on the Threadripper bandwagon due to its generous PCIe lanes and quad channel memory capabilities. However, I have not been able to find any substantial discussion or in-depth investigation of the advantage quad channel memory offers in a real-world application or scenario. Could you please offer some insight? I can try, Jack. I mean, the truth is, memory performance has always been kind of this transient thing, right? So for a very long time, the discussion around memory, main system memory, especially in the days when Ryzen wasn't here and Intel performance was really all that people were looking at, the impact of memory speed had not a whole lot of impact on general performance, right? There was impact when we moved to dual channel. We had triple channel with Nehalem, quad channel. The memory bandwidth numbers would go up, but the actual impact on real world applications and not just benchmarks could be difficult to find. Threadripper is a more interesting discussion because its memory system is very different than Skylake, Kaby Lake, Skylake X, and I feel like we've talked about this on the show and on the podcast quite a bit. So it may not be worth diving into in tremendous detail here, but just that Ryzen and Threadripper are more susceptible to the performance improvements of the memory system around it. In other words, the frequency of the memory directly affects the frequency of the Infinity Fabric that connects all the CCXs and the dies together on a Threadripper processor, and thus performance is more important. Now, to your specific question of the advantage of quad channel memory in real-world applications, it's really going to come down to workloads, right? Some workloads are memory bandwidth dependent, and some memory workloads are memory latency dependent. And the memory bandwidth dependent applications or sensitive applications are going to see an advantage to quad channel memory. Now, I will freely admit that there's just not a lot of those out there. When you get into maybe some high performance rendering, video, maybe not even like 8K video rendering, that's again, it's a lot more on the compute side. There's not a lot of advantage to it, because if you let's put it this way. Here's one way we plan to test this in the not too distant future. The Threadripper 1900X, which is an 8-core processor, has the quad channel memory configuration on it. We compare that to the Ryzen 7 1800X, which is a 2-channel memory controller, and we'll be able to see kind of like what the impact of core count, core performance, clock speed versus something like memory channel capability, right? So we'll be able to directly test 8 cores versus 8 cores, quad channel, dual channel. But you're right. There's not a lot of workloads in which the quad channel is going to make a significant difference. At least not that I have seen thus far. If anybody out there has other specific details of workloads where you do think that occurs, like, feel free to let us know. We'd love to add some stuff to our CPU test benches and our test beds and our kind of software suite for that very specific stuff. You know, a lot of that comes into streaming workloads where the memory is constantly streaming in from system memory into something like a GPU or a processing core as well. So other things to keep in mind as you look at that. Not a lot of insight there, Jack, but hopefully if anybody has ideas or thoughts on this, they can leave them in the comments as well. And we can follow up with this in another mailbag episode. Kyle Bachman has a question here that I don't know the answer to, but I'm going to ask so that I will remember to go talk to some friends at AMD and NVIDIA and come back with a better answer in a future episode. How long does it take for AMD or NVIDIA to make a GPU from start to finish? That's going to be a tough one, right? So if you're talking about something from architectural design through product release, or are we going to talk about, say, we've already developed the Pascal architecture. Now, how do we get GP 104 out of that, GP 106, GP 102, GP 100, right? Because it's gonna vary across that, right? Pascal for NVIDIA is an interesting example because they built, there's one microarchitecture, but then they also built GP100 that has an HBM2 interface, but then they built the consumer variant cards, 104, 106, 102, that have GDDR5. What is the time estimate of something like that? I think in general, especially, you know, having talked with AMD a lot about Vega, right? Vega just came out, and how long has it been in the works? You're looking at probably, like, from an architectural standpoint, from, you know, working on something like that, you're looking at a 3 to 4 year window probably from initial conception, design, productization, manufacturing, release to consumer, which is a long time. But I'll ask for some clarification from these guys to see if I can get some more specific details. It's always interesting when we do these tech days with like the engineers and the architects of something like Radeon RX Vega. And we go and I sit down with Mike Mantor or Raja Kaduri or whoever, and we're talking about it. And, you know, they're passionate. They love this stuff, but they're, you know, on the day of release, when they're being interviewed about Vega, they're on an architecture or 2 architectures ahead, designing parts, figuring out what the next steps are, integrating these different things. So it's always interesting to kind of see. Every once in a while you get them in a question box where they realize they're going down a path they can't really discuss yet, that's always an interesting event that occurs when we're doing this type of stuff. But I'll ask AMD and NVIDIA for just a general idea. I'm guessing, based on my experiences, we're probably talking like 3 to 4 years for a full architecture revamp. If you're just doing a refresh part, probably closer to 2 years from design to productization. Let's see. Scott Jones has a tough one for me. How do you feel about Linux gaming? With Windows 10's privacy controversies and my general preference for the way Linux operates, I hate feeling locked to Windows 10 because of gaming. I know Valve was pushing Linux about a year or so ago, but I no longer hear anything about it. Then Vulkan was supposed to be the saving grace for Linux and game developers alike, yet nothing's changed for a while. What's the situation? The situation, Scott, is that nothing has changed for a while. Valve talked about Linux gaming for a while, and then they came out with SteamOS, right, which was a Linux variant specifically targeting gaming. They had Steam machines, they had a Steam controller, they had Steam Link. And kind of unfortunately, all that seems to have died on the vine, legitimately. You don't hear about Steam OS anymore. Actually, Ken uses a Steam Link, but it's just for, moving your Windows stuff to a TV. I don't know what to tell you. I think Vulkan will only help the situation for sure. The more games that come out targeting Vulkan first, or maybe even just targeting Vulkan second for a second API, will be much more easily moved over to Linux and other platforms for that matter because of it. So I would personally be tracking the uptick of Vulkan acceptance and maybe some laggard response from the Linux gaming market kind of in tow behind it. So I don't know exactly what that gap will be, but there will be some amount to it. And the thing is, you really something needs to spark it, right? I thought Steam OS and Valve would be that spark for it. I also kind of thought the extreme popularity of Mac OS would be a spark for it as well, where people would say like, okay, we can actually more closely target Mac OS, and then Linux would kind of fall in line with that as well. But we just haven't seen it. Now it's possible that somebody like Valve takes another stab at it, and this spark actually lights, and you get a little more acceptance for it, and it kind of snowballs into stuff. And I think a lot of what happened with SteamOS was around Windows 8 and 8.1 and this whole idea of this Windows Store, and they were going to take away control from applications like Steam and your ability to install other applications. A lot of that died away with the release of Windows 8.1 and then 10. But now with Windows 10S, some of that might be coming back into the forefront. So you may see a little bit more aggression in that regard from somebody like Gabe Newell or whoever. Tim Sweeney had a lot of commentary about that type of stuff too. So I don't have a super answer for you, but that's how I feel about it. I don't feel positive. Personally, I will admit, I don't use Linux. I don't really game on it. We have Alex here who does do some of that, and he often laments about the lack of support for some Linux games. But he's also talks up a little bit about every once in a while when some good games are there available. They just tend to be, older games. You're not going to get the AAA new release titles. When Destiny 2 comes out for the PC, you're going to have Windows 10 to play it. Let's see. Let's just do, where are we at here? One more. This one will come in from Matthew Johnson. Excuse me. Hey, man, when is a responsive design coming for PCPer.com? Matthew, that's a great question. Matthew, can you design a responsive site for PCPer.com? Because I will totally bring you into the fold if you guys want to do that. The truth is like, I'm well aware that the PCPer website is kind of outdated, that it needs a refresh. We're kind of working through something that might help in the not too distant future, where we're migrating Drupal. Sorry, we're migrating Drupal versions, but with the same design, in hopes that changing the design after that will be much more simple. I don't know if that's actually the case. We've already invested some money in it to see if it happens. The real pain here is new site designs with all of our database backend complexity are extremely expensive, like way more expensive than I ever thought they would be. More expensive than the original design of the PCPer that you see out there today that included design, coding, database management, setup, and Drupal's a complex CMS. We could go into discussions about different CMSs and transferring of data and migration and all that stuff. It's a horrible, horrible, horrible thing for me to have to deal with. I hate doing it. But that being said, understand that it's desired. Like we also know that Google puts preference on responsive design, so that's another reason why we want to do it. But it's time consuming and it's expensive, and we have so many things kind of going on here in the background that it's tough. It's tough to do. But I'm with you, Matt. I want to do this. If you are a designer and you want to design this and you know Drupal, then you're the perfect fit for what we're trying to do. Please contact me. Leave me a comment here if you do that. So we've got a handful of other questions that we'll get to in the next episode. I want to thank you guys for joining us. Thank everybody for watching these videos and leaving any positive feedback. thumbs up if you like it, like, subscribe, share. I don't know what you're supposed to do at the end of these types of things. But if you have a question, leave it either in the comments on the news story on PCPer.com or leave them in the comments on the YouTube video here, and we filter through those and we'll throw some together on the list for you guys. So thanks. We'll see you next week. Bye.